Okay, so today is review day. You remember we have a test on Friday. Yeah. I'm having issues with the projector today. I can turn it on, it'll shine for about 30 seconds, and then it just shuts itself off. So we're going to have to get through this without me being able to project it up here. So I'll just be reading the questions out loud, I guess. But what you were supposed to do for today to be ready was to have printed off the practice exam, I guess you call it, review exam, and worked it, and then come today prepared with your questions, the ones that you didn't know how to do. And that's all we're going to have time. We won't have time to do every problem, so we'll have to only do the ones you ask about. All right? So, with no further ado, let's get started. Which one you want to do first?
Are we allowed to ask outside?
What's that?
Are we allowed to ask outside?
Yeah, if you have general questions, as long as there's something in it everybody else wants to hear. Go ahead.
Going on back, can we go over finding standard deviation again?
Well, we'll have some where we have to find standard deviation so we can work one in the context of that. What is your general question?
Mine was like the empirical rule and then like finding the not just like the three, but like what you have to like.
Problem like number 7, right? Yeah. So yeah, we'll work those two problems. This problem, I copied the numbers up here before class because it's problem number. It takes too long to read them all out to you. But this is problem number 17. So this is one where you're asked to compute a standard deviation. Okay? So let me slide this over. Should we start there? There's a whole scenario here about reducing pollutants from motor vehicles. And it says 15 randomly selected days during the afternoon, they collected ammonia concentrations. So these are some kind of units, ammonia concentration, 15 times, or on 15 randomly selected days. So then part A says find the mean, the standard deviation, and the 5-number summary of these data. So this is problem number 17, part A. The mean we'll call x bar. Standard deviation is Sx. So how do we find the mean and standard deviation from a list of data like this?
Plug it into calculator.
Right, plug it into your calculator. And I'm going to try to stand here so that I can't get the camera to point at it without me being in the way. But. All right, so get those entered into a list in your calculator. I'll see if I can beat you. Done. I already had a class this morning. Oh. Are you serious? Of all the possible days, this is the second worst day to leave your calculator at home.
My equation's so hard last night.
What's the worst day to forget your calculator? Friday, test day. Right? So you already have the data in L1, so don't go changing them. Right? So you're going to enter these into L1 or L2 or whatever list you want. Right? Then to get after you get them entered into a list, how do you find the summary statistics? One of our stats. So you're going to push the stat button and then go over to calc and then one var stats. Right? If you put them in L1, you can just hit enter again and it'll default to L1. If you put them in L3, then you need to tell it L3. But by habit, I would go ahead and just tell it L1 so that you're sure. Okay, you got it already? What's x bar?
1.46.
1.46. Okay, give me one more decimal place.
If it's rounded, it'd be 1. It's 07.
I have 2.
Okay, and what he did, I'll see at least 3 people on Friday that I'll have a question like this where I'll say, give me the mean, standard deviation, 5-number summary, and all that stuff. And there'll be somebody whose numbers are real close to correct, but they're not quite right. And what does that mean? They got one data point entered wrong. So check your data entry, right? So when you enter on Friday, when you come in and you enter data into a list, go back through and double check it all, right? Take that 10 seconds, get that before you go to do this, because you won't have any way to know whether it's right or not. The only time is if I happen to make a multiple choice question and go, well, my answer's not there, right? Well, then you probably have a data entry error. But I'm not nice enough to do multiple choice all that much. So, all right, so what's the standard deviation? 0.06. Give me one more, please. 6.066. Okay. All right. So that is. Oh, we need the 5-number summary. So the 5-number summary. What are those 5 numbers? Okay. What are they called first? The min. Okay. Good. So the minimum, Q1, median, Q3, and max. So the minimum in the data set was 1.37, Q1, 4.1, median, 1.44, Q3, for what? 5.1. And then the max, 1.55. 59. Okay? All right? What's the next part say? What's that?
Find the IQR.
Find the IQR. So part B says find the IQR. What does IQR stand for? Interquartile range. And it's computed how? Q3 minus Q1. Right? It's the range between the quartiles. Right? And so Q3 is 1.51. Q1 is 1.41. So subtract them and you get 0.1. So the interquartile range is 0.1. All right. What's the next part say? The z-score of the minimum. So by definition, how do you compute z-scores? Okay, so we'll call it x, the value minus the mean, divided by standard deviation. Good? So we have, they say z-score for the minimum. So the x is the minimum, so 1.37, minus the mean, which is 1.462, divided by standard deviation 0.66. Okay? Now, let's talk a little bit about rounding. If you rounded the mean and the standard deviation to 2 decimal places, you're going to get a different number, right? So, we usually want you to keep more decimal places of accuracy during intermediate calculations. Then only round your final answer. Otherwise, you're going to have round-off error built into it. Okay? I'm not going to get too picky about rounding. If I can tell, oh, they did it right, they just rounded this number to 1.46, then that's probably fine. On online homework, they're more picky about it. So what do you get when you do all this? And make sure you can do this. Don't just say, oh, yeah, I know how to do that. On a calculator, if you enter the numbers in a certain way, you won't get the right answer. So, negative 1.394. Okay? That's actually a different number than my last class got. But I think they gave me maybe 4 decimals on this standard deviation. Theirs was like negative 1.4 something, but it was real close to this. Now, I'm also always harping on you, when you get an answer, look at the answer for 5 seconds and decide, does that look about right? Can you have negative values for z-score? Sure. See, I was trying to trick you and say, oh, no. Yeah. Z-scores can be negative. What does negative mean? It means it's below the mean, right? So the minimum is below the mean, so you're going to get a negative value, and it's, what is this number, the interpretation of this number? Negative 1.39 what? Good. That's the number of standard deviations below the mean, right? So one standard deviation is 0.066, and 1.37 is about 1.5 of those. 1.4 of those left of the mean. Okay, is there anything left in this one? Oh, box plot. Yeah, we got to do a box plot using these 5-number summary. Right? So, let's do it here. So a box plot, you need to start with a number line. There should be one on the page, but and then you need to span the data, the range of the data. So 1.4, 4.5, 5, 5.5, and 6. So 1.45, 0.50, 1.55, 1.6. My max was 1.59, so I'm good there. And 1.37 for min, so I've got enough room. All right, so we start with the box. Where does the box go from? Okay, you can start with the median, which is 1.44, which would be just to the left of 1.45. And you draw a vertical line. Then Q1 and Q3. So Q1 is 1.41. Draw the left edge of the box. Q3 is at 1.51. So draw the right edge of the box and connect them. Right? So what percent of the population is going to fall in between those two numbers? 50%. So, or of the data. 50% of the data is in between the box. 25% here, 25% there. Then all that's left are the whiskers. Where do the whiskers go? To the min and the max. So the min is 1.37 and the max is 1.59. So just before 160. Okay, so there's your box plot. Is this distribution symmetric? No, not perfectly. It's not horrible, but this whisker is definitely longer than this one, and the median is closer to the left edge of the box, so that side of the box is longer, so things are stretching out more as you go to the right. So this has a slight right skew to it. Yes?
So for the box, you have your median and to the left, that's the beginning of the first quartile. That's the second. Right.
Let me label here. So that's Q1. This is Q2, which is also median. And this is Q3. Is that what you were asking?
Yeah.
Okay. And then this is the min. And this is the max. Got it? All right. Next question. Seven. You can't go backwards. I'm just kidding. Oh yeah, 7. 7 is very fun. 7 starts off reading about something about human engineering and weights of people, right? So you need to have an idea of the distribution of weights of people, so you know how strong to make elevators and such. Right? So what do they tell us? Read it to me. Weights of humans are
173 pounds.
Okay. The mean weight of 173 pounds. Standard deviation of 30. Now is that an X bar equals 173 or a mu equal 173? Not that it matters for this particular problem, but I heard both answers. It's X bar if what? If it's a sample. If it's the whole population, it's a mu. Which is it? It says, based on data from the National Health Survey, the weight of adult males in the U.S. Well, that one's kind of tricky. So it is based on a survey. So earlier I wrote it as mu because they're talking about, it sounds like they made inference. They said, based on this survey, in the United States, it's this. So they're talking about the whole population. For working the problem, it doesn't matter. But I'm just trying to give you practice about sample and population. But I would accept either answer in this case because they do say, based on this survey, the mean was 173. So X bar. Right? Okay? Then what does it say about shape of the distribution? Bell-shaped. So I'm going to draw a bell-shaped distribution. Okay? Now we start labeling that distribution. What number goes right under the peak? 173. In a symmetric distribution, the mean is right in the middle. Then one standard deviation on each side of the mean takes you how far out?
30.
Yeah, that's the answer to the question I ask. 30. But what I mean is, where is that on this picture? Is 130 plus 173 is 203, right? Is 203 out here? Is 203 right there? Where is it?
Halfway, a third of the way to either side.
Good. Halfway down the hill is what he said. You said something else. Right? So halfway down the hill. If you want to get technical mathematically, like I like to do, that's the inflection point. Does anybody know what that means? Have you had calculus yet? What is inflection point? Good. It's where it goes from being concave down, so my hand is cupped down, to over here my hand is cupped up. Right? The point where it switches is called an inflection point, and that's where one standard deviation is. But it's halfway down the hill. Right? So, and then halfway down the hill on the other side is about right there, and that would be at 143. But what they ask then is, what percent, or I think they say proportion, right? What proportion of the population falls between 203 and 263? So 263 is how many standard deviations? 3. So if I go one more standard deviation, I'm at 233. And I got to go one more to get to 263. So I'm going to shade the region that they want. So proportion of the population is the same thing as area under this curve. The total area under the curve is 100%, or 1 as a proportion. Now we use what to get the rest? What kind of a problem is this? The empirical rule problem. How do I know it's an empirical rule problem? Okay, it's bell-shaped and symmetric, and the numbers they quoted are nice integer multiples of the standard deviation. Right? Then if you see that happening, oh, this is empirical rule. Right? Plus, it may have said, use the empirical rule to... But I won't always be that nice. All right, so let's remind ourselves what the empirical rule is. Mu plus or minus 1 sigma is what percent? So in between these two dotted lines, 68%. So since this problem's done as proportions, I'm going to put 0.68 instead of 68%. Same thing. All right, so then mu plus or minus 2 sigma is 0.95, and mu plus or minus 3 sigma, pert near everybody. Okay? So now we start using these numbers and subtracting things, and we can figure out what we need. Okay? So in here is 0.68. So how much would be over here, left of this dotted line? Good. 16. And the way you do it is say, well, if 68% or 0.68 is in between these two numbers, how much is not in between those two numbers? How much is left over from 0.68 to get to 100 or to get to 1? 1 minus 0.68 is 0.32. Now, by symmetry, half of that 0.32 is down here, and half is up here, right? So this is 0.16, and from here to infinity is 0.16. Right, now, if you're really good at test taking, multiple choice test questions, you can already pick out what the right answer is. Right, look at the answers that are there. One of them is 0.16. Is that correct? No, why not? Because it stops here, right? 0.16 goes all the way to infinity, but what's the area of that little sliver? Not very much. So you need a number that's slightly less than 0.16, and there's only one number like that in the choice list. But let's go ahead and work it, just in case I don't make it multiple choice. I need to find the area or the proportion of that sliver. I've already heard a couple of you say it, but do exactly what we did to get this 0.16 and 0.16. We started with one standard deviation and said, well, 1 minus the part in the middle. Well, how much is in the middle between plus and minus 3 standard deviations? 0.997. So 1 minus that, 1 minus 0.997 is 0.003. And now it's only half of it that's up there. The other half is down here. All right? So half of that is 0.0015. So that's this 0015. So the answer is 0.16 minus 0.0015, which is 0.1585. Answer A. See how easy this is? Man. He's got a pop-up here. Sorry.
I have electronic hiccups, so I get like one of those an hour.
Oh, really? Well, don't do it again. Just kidding. Next question. Was that all of that question?
Yes.
There's no other parts? Okay.
Can we go over 24?
24, okay. So 24, oh yeah, 24 is a problem I took straight out of the Hawks learning system. So I think you had a homework problem that was very similar to this, and I just kind of captured it and dropped it into here. So the numbers would have been different probably, but I'll read it. It says, a supermarket selected a sample of 250 of its customers and measured how long they took to be served. If too many wait too long, they'll hire more people. Specifically, they would like at least 82% of the customers to check out in 80.2 minutes or less. From the data, the 90th and 60th percentiles were computed to be 10 minutes and 6.6 minutes, respectively. The range of the data was 14 minutes, and the fastest anyone was checked out was 1.2 minutes. This is what leads to test anxiety, right? So that's okay. I want you to learn when you probably hated algebra and other math classes because of the word problems. I hated the word problems. It's because it's like information overload. But the problem is in statistics, they're all word problems. That's all we get are word problems, right? So here's what you do. You take a big long paragraph like that and you read it once. You allow yourself to, I don't have that moment of panic. then just go back, start again, and start writing down the pieces of information that they're giving you and what they mean. And sift through what's important information and what's not important information, right? So now I go back and I say a sample of 250. So what number are they giving me? N equal 250. Okay, my sample size was 250. Then it says a bunch of stuff about waiting at a counter and all that, and it says at least 82% of the customers be checked out in 8.2 minutes or less. That's extra information. We never need that information. If you go down and read those questions, that's extraneous information, right? What that sentence says in statistical language is we want the 82nd percentile to be 8.2. That's what it says, right? But we don't need that. They never ask about that. So we'll ignore that. Then we'll go down. It says from the data, the 90th and 60th percentiles were 10 and 6.6. So 90th percentile, remember this is my notation. They don't show it this way in the book. They just write it all out, 90th percentile. But P sub 90 is 90th percentile. And that, they tell us, is 10 minutes. And then P what is the next one? 60th, and it's 6.6 minutes. Okay? And then next piece of information, the range of the data is 14 minutes, and the fastest anyone was checked out was 1.2 minutes. Ooh, 1.2. What's that number? That's the min. So the min was 1.2. The smallest number, the fastest anyone was checked out. Then they tell us the range is 14. The first question they ask is what is the longest time? So they want the max. Well, if you know the min, you know the range. What's the definition of range? It's max minus min. So the max is the range plus the min. Just algebra. So this is 14 plus 1.2, which is 15.2. Okay, so that was easy. Part B, based on the given information, determine if the following statement is true or false. The median of the data exceeds 6.6. The median is P what? P50. Can it be greater than 6.6? No, because the 60th percentile is 6.6. The 50th percentile must be where? Less than or equal to 6.6, right? Because by definition of percentile, this means 60% of the people are less than or equal to 6.6. So you can't have only 50% that are less than or equal to some number that's bigger than that, right? Now, could they be tied? Could the median also be 6.6? Sure, if there's a lot of repeats, right? If there's a lot of duplicate numbers, 6.6 occurred, 63% of the time and also 43% of the time, then it would be both numbers. But it cannot be greater than. It can be greater. It can be less than or equal to. All right, so it's a false statement. All right. Part C, approximately how many customers waited 6.6 minutes or less? How many? Not what percent, but how many waited less than or equal to 6.6? Well, what percent waited less than or equal to? 60%. So I need 60% of n, right? So 0.6 times 250 gives me what? 150? So 150 is the answer. Approximately 150. Okay. And they say approximately because there could have been ties, and if there were ties, and 6.6 was also, the 63rd percentile or whatever, there might have been more. But it should be close to that. So the last part, what percentage of the customers were checked out between 6.6 and 10? 30%. 90% were checked out by 10 minutes. Only 60% were checked out by 6.6 minutes. So in between the two is the difference of the percentage. So part D is 90 minus 60, or 30%. Okay? Next question. Yep.
13 and 14 makes sense for what we're
Okay. So 13 and 14. 13 says, two primary graphical displays for summarizing a categorical variable are blank and blank. Okay, bar graph is one, and a pie chart. Those are the ones that we had for categorical data. We had some others too, but those were the main two that they focused on. Pie chart and bar graph. Okay, 14 says a blank is a non-graphical display for a categorical variable. That's almost a trick question, but did you get an answer? Okay, non-graphical. And so no pictures. That's what that means. A table. And what kind of a table? Frequency table. So a frequency table is a non-graphical way to display a categorical variable. Okay? And I saw a hand over here as I was... Somebody over here had a question? No? 11? Okay. Oh. 11 says the shape of a distribution is often described as either blank or blank. Bell-shaped or skewed. Or I would accept symmetric or skewed. Or, right. Yeah, you could use normal. The word normal means bell-shaped and symmetric. Right? So normal or skewed are the main two that they would be looking for. Okay, next question. 26. So we're getting down into the computation ones. Okay, I'm gonna copy that table up here, but I'm gonna have you read me the numbers so I don't have to keep walking back over there and looking. So it's a frequency table. What number was it? 26? So it has class, and what's the first class? Okay, the next one is 48 to 65. And that's it? Okay. And then the frequencies. 12. Okay. So you have this frequency table, and it says they are scores on a test. Part A says determine the class width. How do you get class width?
How much is included in each class?
Is it 47 minus 30 or 48 minus 30? It's 48 minus 30. Class width is the distance between the start of one class to the start of the next class, or the end of one class to the end of the next class. Doesn't matter whether you do the lower limit or the upper limit, but it's class to class, not within a class. Because that would depend on what you're using as your rounding. Right? So from 30 to 48 is 18. So the width is 48 minus 30 equal 18. And I use the top two classes. You could use any of the classes, but you should have 18 units in between any two of them. Okay, part B says determine the number of scores between 29.5 and 65.5. What are they giving us, those numbers? 29.5 and 65.5? What are those called? Boundaries. Those are called the class boundaries. So you notice 29.5 is just before the start of this one, and 65.5 is just after the end of this one. So they want to know what's in these two classes. So add those two numbers together, 25. Okay, and then the hard part. Next two we'll do together, C and D. Compute the mean and standard deviation. And notice it says approximate mean and approximate standard deviation, because if you're in a frequency table, you're not going to get it exact. Right? So how do you do that? Calculator, definitely. Find the midpoint of each class. So let me erase this 29.5, and I'm going to write over here, I'm going to add a column. Point. And you're going to put those midpoints into your calculation list. So what is the midpoint of the first class? 38.5. And where did you get 38.5?
47 plus 30 divided by 2.
Good. It's the average of the lower and upper limits within the class. Right? So 30 plus 47 divided by 2 gives you 38.5. All right, and the next class? 56. No. How far is it between those midpoints? 18. It's going to be the class width. So you don't have to actually do the average every time. You can just start adding 18 as you go. Right? So the next one would be 74. Yeah, I went 74.5. The next one, 92.5 and 110.5. Okay? So then you'll take those numbers and put them in L1. Or if you've already used L1 for something and you don't want to throw away that data, you can put it anywhere you want. But just remember where you put the midpoints and where you put the frequencies. So then put the frequencies into L2. Then once you have those entered, you'll do one var stats, push the stat button, go over to calc, select the top one, which is one var stats, and then you're going to do L1 comma L2. The comma L2 tells it it's a weighted mean. You're going to take the mean of the midpoints, but weight them by their frequencies. If you have the newer version, it'll say, I think it's list, and then freq list. So you'll say L1 and L2, like that.
So this is how you do a weighted problem?
Right. Yeah. If they have classes like this, then you have to do the midpoints. If it's a discrete variable, and maybe this is just 0, 1, 2, 3, 4, then you would just enter those numbers in L1. And then do a weighted by L2. Got it? So, has anybody got it done? What is X bar? 73 point what? 55. Okay. And the standard deviation? 25.78. Okay? You're frowning like you didn't get those numbers. You didn't. Okay, well, I'll let them work that out. Is anybody disagreeing with those numbers?
I might have punched it wrong.
Okay, yeah. Always check your data entry. See if you've got something entered wrong. But I think those look right from what I remember. But okay, next question. Yes, 18. All right. Okay, yeah, 18 is, I'll tell you what, I'm going to slide this board clear over. 18, they give you a picture of a histogram. And so I'm going to try to sort of duplicate that over here, but I'm not going to be super neat. Then it drops down to about there. Up, down to 1, up to 3. I did that pretty good, didn't I? First question. Describe the shape of this distribution. Skewed right. Skewed to the right. How do you remember right and left? It's where the tail points. Right? So this is pointing off to the right, so this is skewed to the right. Okay, the next question says, what information can you get from the dot plot or a stem and leaf plot that you cannot get from a histogram? The exact data values. Just like this is an approximate mean and approximate standard deviation because we don't have the exact data values. All we know, there were 11 people that were in between here somewhere. But a stem and leaf plot would show you exactly what those numbers were. So part B, exact data values. Then part C says, what percent of the 47 states were above 3.0? And 3.0 is right there. It's that boundary. So above 3.0 are these 4 bars. So all you have to do is come over here to the y-axis and figure out the heights of those bars and add them up. Because it's a frequency histogram made with counts, not with percents. If they were percents, you could just get the percents, add them together, you'd be done. Since they're frequencies, we've got to add them together and then divide by 47 to get the percent. So how tall is this bar? All 3 of these bars. They're at a height of 1. It's kind of hard to tell because they don't have gradient here under the 5. But if you look at it, you can figure out, yeah, that's got to be a 1. And this one is a 3. Okay, so I add those numbers together, and they add up to 6. So there's 6 states total that were greater than 3, but they ask for what percent of the states are greater than 3. So it's 6 out of how many? 47. So that is, as a decimal, what is that? 127? 128? If you go to a tenth of a percent, 128, so 12.8%. Okay? Everybody understand that? All right. Next question. Oh, there is a D. You're right. This histogram shows frequencies. If you were to construct a percent histogram instead of a frequency histogram, how would the shape change, if at all? It wouldn't change. So the shape, all it changes is the scale on the y-axis. But the relative heights of the bars would be exactly the same. All right? So there'd be no change in shape. Okay, next question. 15. 15 says, every year the U.S. Census Bureau releases the current population report based on a survey of 50,000 households in the United States. Identify the population, the sample, and the subjects for this subject, or for this study. Okay? Population is the U.S. households, right? Because they say a survey of this many households. So the population is all of the households. So all U.S. households. So what's the sample? 50,000 households that were selected. Right? And then what is the subject? A single household is a subject. So each household is a subject. When people get confused, again, that's one of those words that has different meanings. When I say, what's the subject? They'll say, oh, this study's about the population report. That's the subject of this study. Well, that's a different meaning of the word subject. What we mean are the individuals that are being surveyed. And here it's households. Okay? Just a few more minutes left. What else? Nobody has asked about the
25C.
About problem number 25, which is the linear regression problem. So I'm glad you asked that. So I figured somebody would ask it, so I copied the data over here on the board. So let me slide that over here. So this is, it says the following data gives the number of hours students spent studying and their corresponding grades on their midterm exam. So we have the hours and grade. Which would be the explanatory variable and which would be response variable? The hours that you study for Friday's test will explain what your grade is on that test. Right? So this would be the x variable, and this would be the y variable. Put the x variable into L1, and put the y variable into L2, or whatever list you want. But so while you're doing that, the first part asks for the correlation coefficient R. And then B asks for the coefficient of determination. Okay, so once you have these data entered into your calculator, how do you get the correlation coefficient? Right, lin-reg t-test. So you're going to push the stat button over to tests, then down to lin-reg t-test. Okay? Then it's going to ask you for X list and Y list. So tell it wherever you put your X variable and wherever you put your Y variable. Probably L1, L2. Then just go down to calculate. Ignore all that junk in the middle. There's stuff there with betas and rows and greater thans, and just ignore all that. Go down to calculate. And when you go, you'll get the first page of output, and then scroll down. Use your arrow button to scroll down. You'll get to the second page of output, and the very bottom will be R. So what does it say R is? 0.979. Okay? Is that strong, weak, or moderate? That's very strong, positive correlation. So the more hours you spend, the higher your grade. As one goes up, the other goes up. It's positive. Right? Coefficient of determination. What is the coefficient of determination? That's R squared. Now here they say, find the coefficient of determination R squared. On the test, I might not be that nice. I may not say R. I may say, find the correlation coefficient. Find the coefficient of determination. So you better know what those things are. Right? But R squared should also be given by your calculator. And what is it? 0.95 what? 959? Okay. And then it says, and interpret. So how do you interpret that? 95.9% of the variation in test scores can be explained by number of hours studied. All right? I'm out of time, but the regression equation, B0 plus B1x, calculator uses what letters for B0 and B1? A and B. So it should be in the same output that you got your correlation. You'll see an A and a B. Then you'll fill them into this equation. That'll be your regression equation. Then one of the parts asks you to make a prediction. What's the predicted value when x is 4? So then what do? You just plug the 4 into the equation after you put the numbers in, and that'll be your predicted value. Okay? So we will see you on Friday. When you get here on Friday, there will be some online students that'll be taking the test with you, and some of my students from the earlier class that may run a little long. So don't be worried by that. You guys will be allowed to run a little bit long also, because there's no class coming in after us. I will not be here. It'll be Dr. Charwood that's proctoring your exam. So we'll see you there.